So recently I built an algorithm to play Atari games. I've always loved playing video games, and with my recent interest in AI, I thought this would be the perfect project. So essentially what I did was I replicated DeepMind DQN to play Atari game. And today I'll be going over how I built this Atari game. So DQNs are essentially deep learning combined with reinforcement learning, and that's what I'm going to be talking about today. So I'm going to assume that you know the basics of reinforcement learning and at least a little bit about Q-learning. If you don't, please check out my article on that first. Now, Q-learning is a simple yet powerful algorithm that pretty much creates a cheat sheet for our agent. This helps the agent figure out which actions to take and at what state to perform them at. But what if the cheat sheet's too long? And that's the problem with Atari game. Cheat sheet's way too long. For example, let's just imagine an environment with 10,000 states and 1,000 possible actions for each state. That leaves up to 10 million cells mapping out each single action, and things can get out of control pretty quick. Now it's pretty clear that we can't infer Q-state values from previous Q-state values. There's two problems with this. First, the amount of memory required, and the second would be the amount of time required, which would be unrealistic. So here's the thought. What if we approximated the Q value? Well, this is exactly what DeepMind did, and this led to Google acquiring them for $500 million. They began to approximate Q values using a neural network from machine learning. So the problem that was presented before between combining reinforcement learning and neural networks was because of correlated data. And this was probably the biggest issue stopping everyone, and that's why it took so long for this Atari DQN to come out. Now this was solved using the experience relay, which I explained in my article as well. Now I'll just show you a few clips from the DQN and how it actually